factor theorem, and let's state the factor theorem first. Now, if p of x is a polynomial of degree greater than 1, therefore the degree of the given polynomial, that is p of x, degree of p of x is greater than 1, and here we have let a be any real number. Now a is the any real number, then what it state is x minus a is a factor of the given polynomial p of x if p of a equal to 0. Now in the remainder theorem we have already studied that p of a is a remainder when p of x is divided by x minus a. Similarly, if p of a is equal to 0, that means if the remainder is 0, then x minus a is a factor of p of x. So let's try to understand this factor with the help of a simple example. For example, if we take a number 9, so when you divide this by 3, you will get 3 3s are 9, and when you subtract it, you will get remainder 0. Since the remainder is 0, what we call this 3 as? We call this 3 as, okay, we'll write remainder is equal to 0. This implies that 3 is a factor of 9. Similarly, for example, if we divide 9 by 2, you will get 2 4s are 8, and when you subtract it, you will get 1. Now here the remainder is not equal to 0. Therefore, what we can write, 2 is not a factor of 9. Similarly, in polynomial, we have already studied about division of a two polynomials. So let's take an example. For example, if we have x square plus 3x plus 2. So now let's see whether now this is the given polynomial p of x, and let's take a g of x, a divisor which is equal to x plus 3, for example. Now we don't know whether x plus 3 can divide this polynomial or not. So what we can do is we can find the remainder with the help of a remainder theory. What we do, so we'll take x is equal to minus 3, and we'll find the value of the given polynomial at x equal to minus 3, which is equal to minus 3 square plus 3 times minus 3 plus 2, which is equal to minus 3 square is 9, and plus into minus is minus 3 3s are 9 plus 2. So 9 minus 9 is 0, which is equal to 2. Since p of minus 3 is not equal to 0, this implies that x plus 3 is not a factor of given polynomial in variable x. Now we'll try to understand the factor theorem with a few more examples. First example, that is, examine whether x plus 2 is a factor of x cubed plus 3x square plus 5x plus 6. Now here the x plus 2 is a linear binomial, whereas x cubed plus 3x square plus 5x plus 6 is a cubic quaternomial, because there is a 4 term and the highest power of the variable is 3. Therefore it is a cubic polynomial. And also of the 2x plus 1, again 2x plus 4 is a linear polynomial or linear binomial. So we'll use the factor theorem here. Now it is in the first case, that is, let's take p of x equal to x cube plus 3x square plus 5x plus 6. Now this is the given polynomial, and we have to check whether the x plus 2 is a factor or not. Therefore we have x plus 2. So this means x equal to minus 2. So we'll find the value of the given polynomial at x equal to -2. So what we do, we write p of -2, which is equal to, now instead of x we'll write -2 raised to the power 3 plus 3 times -2 raised to the power 2 plus 5 times -2 plus 6. So you'll get -2 cube. Now negative raised to the power 3 is, you will get minus only, and 2 raised to the power 3 is 2 4s are 8, sorry, 2 2s are 4, 4 2s are 8. So you will get -8 plus 3 times -2 square is plus 4, and plus into minus is minus, 5 2s are 10 plus 6. Here you will get, we will write -8 plus 3 4s are 12, and -10 plus 6 is -4. This is equal to -8 plus 12 is plus 4. We are left with -4. So 4 minus 4 is 0. Therefore, P of -2 is equal to 0. This implies that x plus 2 is a factor of the given polynomial in variable x. First one is done. Now we have to check for the second one. In the second one we have polynomial in variable x, which is equal to 2x plus 4. Again we have to check whether the x plus 2 is a factor or not. So what we do is we take x equal to -2. So P of -2 is equal to 2 times x equal to -2 plus 4, which is equal to, plus into minus is minus, 2 2s are 4 plus 4. So -4 plus 4, it will get cancelled, you will get 0. Therefore, the given polynomial, that is P of value of the given polynomial at x equal to -2 is 0. Now this implies that x plus 2 is also a factor, of P of x, that is 2x plus 4. Now this is how we use the factor theorem to check whether the given polynomial is a factor of the another polynomial or not. Let's move on to the second question or the second example. Here the question says that find the value of k if x minus 1 is a factor. Now in the previous question we are asked to check whether the given polynomial is a factor or not. But here it is already given that x minus 1 is a factor. So let's write the polynomial in variable x is equal to 4x cube plus 3x square minus 4x plus k. Now it is given that x minus 1 is a factor. So factor theorem states that if x minus 1 is a factor, then P of 1 should be equal to 0. So let's find P of 1, or the value of the given polynomial at x equal to 1. So we'll write 4 times, instead of x we'll write 1 cube plus 3 times 1 square minus 4 into 1 plus k equals 0. So 4 times 1 cube is 1 plus 3 times 1 square is 1 minus 4 into 1 is 4 plus k, which is equal to 0. So we'll write 4 1 is 4 plus 3 minus k plus k equals 0. And 4 minus 4 is 0. So we are left with 3 plus k equals 0. Now this implies k is equal to -3. Now this is a different type of question based on the factor theorem. Okay, now let's move on to the third example. Okay, in the third example, we have to use the factor theorem to determine whether the g of x is a factor of p of x in each of the following cases. Now we'll start with the first one. Here the p of x is equal to 2x cube plus x square minus 2x minus 1, and the given g of x is equal to x plus 1. Now here the question states we have to check whether g of x is a factor or not. So what the factor theorem state? Factor theorem state x plus 1 is a factor if p of minus 1 equal to 0. So we have to check whether the value of the given polynomial at x equal to minus 1. Since here it is plus, so we have to take minus 1 equal to, we have to find that is 2 times x is minus, minus 1 raised to the power power 3, and plus minus 1 raised to the power 2 minus 2 times minus 1 minus 1. Now this is equal to 2 times minus 1 raised to the power 3 is minus 1, plus minus 1 squared is plus 1, and minus into minus plus 2 1 is 2 minus 1. Now this is equal to minus 2 plus 1 plus 2 minus 1. So minus 2 plus 2 it get cancelled or 0, and plus 1 minus 1 again 0. Now this is equal to 0. Since p of minus 1 equals 0, this now this implies that x, or given g of x, is a factor of p of x. So let's move on to the second one. Okay, we'll draw a line like this. Second one is, that is x cube plus 3x square plus 3x plus 1, and we are given g of x equal to x plus 2. So what we have to do, we have to find the value of given polynomial at x equal to minus 2, which is equal to x minus 2 raised to the power 3 plus 2 times minus 2 square, it's 3 times minus 2 square plus 3 times minus 2 plus 1. This is equal to minus 2 cube is minus 8 plus 3 times minus 2 square is plus 4, and plus into minus is minus, 3 2s are 6 plus 1. This is equal to minus 8 plus 3 4s are 12, minus 6 plus 1 is minus 5. Now this is equal to minus 8 plus 12 is plus 4 minus 5. This is equal to minus 1. Since p of minus 2 is not equal to 0, this implies that given g of x is not a factor of p of x. So I request you to do the third one. Do it by yourself. Take a moment here. Okay, and then we'll move on to the fourth example. Now fourth example is similar with the second one, that is to find the value of k if x minus 1 is a factor of p of x in each of the following cases. So now here also it is given that x minus 1, this x minus 1 is the factor of all the p of x here. So we are supposed to find the value of k. Let's do the first one. Okay, now here given p of x is equal to x square plus x plus k. Now it is given that x minus 1 is a factor of p of x. So this implies that p of 1 is equal to 0. So we'll find p of 1. Instead of x, we'll write 1. So we'll get 1 square plus x equal to 1 plus k equals 0. 1 square is 1 plus 1 plus k equals 0. 1 plus 1 is 2 plus k equals 0. Therefore, k is equal to minus 2. First one is done. We found the value of, okay, we'll take the pen. Okay, now the second example, Okay, now the second one is question number 2, that is p of x is equal to kx square minus square root of 2x plus 1. And again here x minus 1 is a factor that is already mentioned in the question. Therefore, you'll find p of 1 equals 0. Since it is a factor, therefore remainder is equal to 0. So we'll find the p of 1, that is k times x is 1 square minus square root of 2 into 1 plus 1 equals 0. So 1 square is 1, so k minus square root of 2 plus 1 equals 0. K equal to, we'll move these numbers to the right hand side, you will get square plus root 2 minus 1. So this is the value of k. Since we cannot add or subtract the rational and irrational numbers, so we'll leave the answer as it is. And I request you to do the third and the fourth questions. Thank you.